All right, little by little, we're making our way through the review for the final. Let's go ahead and go through the review for Chapter 4 now. Now, Chapter 4 was all about quadratics, and quadratics means that we have an x squared. So just about every problem that we studied have an x squared. It also dealt with imaginary numbers. So let's go ahead and take a look at our quadratics. Number one, complete the following. So I'm going to give you a problem. The important thing about this problem is that you are able to identify that this is in vertex form because of the parentheses and there's a squared. So that means the vertex is very easy to find. It's opposite of what's inside parentheses, so -3, and exactly the number in the back for the vertex. That tells you your middle number, and then you surround it. Now you can plug those in by hand. There's nothing wrong with that. The axis of symmetry is x equals that x value, so -3 in this case. The domain for this parabola is x, is all real numbers because it goes forever left and forever right. And the range in this problem is y. Let's take a look. So we have a negative in the front, right? So that tells you that the parabola is going to point upside down. So we're going to do y is less than or equal to the y value of 4. And I'm pulling those numbers from here and from here. The vertex is the most important point. And because this parabola opens down, it has a maximum. It does not have a minimum. Again, it has a maximum because it points down, because it was negative in the front. And the maximum is the y value of 4. So I personally think just using your calculator to plug things in is probably the easiest way. You might disagree with that. You can plug them in by hand, by all means. So I'm going to go to y equals. It was x plus 3. I believe it was a plus 4. Forgot to square it. So I have negative x plus 3 and then plus 4. I think I can dual screen here. I'm just going to verify to make sure I plugged it in right. I did. And I'm going to go to my table. Again, you can plug this in by hand. There's nothing wrong with that. If your calculator does not allow you to type over top of it, please make sure you hit Shift and Zoom. I'm sorry, Shift and Window. And you want to make sure your independent is on Ask. All right, so I need -5, which is going to give me 0. I need -4, which is going to give me 3. Just double checking the -3 gave me 4. -2 needs to give me a 3. And -1 needs to give me a 0. That way I have a mirror image. I'm skipping my whole number, so that should be okay. All right, let's put, and if you want to hit graph, you can see what it should look like when we're all done. So let's plot our points. -5, 0. 1, 2, 3, 4, 5. I think there was a -1, 0. 1, 2, 3, 1, 2, 3, 4. Just plotting my points. -4, 3. -2. And there's the shape. The shape matches what we have showing on the calculator. So we know that we did that problem right. So again, it's very important that you can compare number 1 on the review to number 2. Number 2 is not, number 1, remember, was in vertex form. Very important. Again, very important that you can label the different types of forms. So number 1 was in vertex form. Number 2 is not in vertex form. There's no parentheses. Number 3 is in standard form. You need to be able to see that it's a parabola because it's x squared. So the vertex is more difficult. So what I'm going to do is write x equals opposite b over 2a. So opposite b is +8 over 2 times a is 2. Don't type that in your calculator in one step. You'll get it wrong. That's 8 over 4, which reduces to 2. So that's just the x value of the vertex. So I can zoom in here. And I know it's going to be 2 comma something. I know 2 is going to be my middle number. I just solved for my axis of symmetry. So just doing that work is a huge help. I can put it in my y equals in my calculator. I'll even write that there. You should write that there too. So we have 2x squared minus 8x plus 3, shift and graph. And I know that I got to go a little lower and a little higher. So 0, 1, 2, 3, and 4. 0 gives me 3. 1 gives me -3. Oops. 2 gives me -5. 3 gives me -3, which is what I want to see. And 4 gives me 3. So I have that really nice reflection because everything's in terms of whole numbers. My calculator did the work for me for plugging in for the y value for -5. Now you can plug 2 in by hand. If you didn't like the way that I use the calculator, you can definitely plug 2 in by hand. There's nothing wrong with that as long as you're very careful. I promise you will get -5 if you do. The domain is not a word problem. It goes forever left, forever right. So all real numbers on my x's. My range, since this is positive in the front, it's going to open up. So my range is greater than or equal to my y value of -5. And again, because it opens up, I have a minimum, and my minimum is my y value of -5. From here on out, it's just a matter of plotting my points, 0, 3, 1 and -3, 2 and whoops, I did -1, didn't I? There you go. 2 and -5, 3 and -3, and 4 and +3. And you can just check it with the graph. It does look pretty good. This one has been vertically stretched because it has that 2 out in front, which is why it looks a little skinnier than the other one we did. Now, number 3, I am certain that I gave you a website for this, but you can do this by hand. If you want to do it by hand, please look at the notes for Chapter 4, Section 3. However, I am going to go to Schoology, and I'm going to go to Chapter 4, Section 3, because I'm almost 100% certain I gave you a website. There it is. Let's take a look. Did I give you a website? Okay, so I'm hoping that this website will work because our calculator cannot do quadratic regression. So let's take a look. I think I'll be able to remember pretty well. So the x values are going to be -2, 8, not 8, -2, 0, 4. And the y values will be 8, -4, 68. Now something maybe you guys should recognize is like how easy it was for me to go to Google and just type like quadratic regression calculator. And it looks like there is our equation right there. Y equals 4x squared plus 2x minus 4. And if you're not sure if that is correct, you could plug those x values in and get those y values out to prove that you are right. What I'll do real fast is I'm going to plug in 4, and I'm just going to double check that I'm going to get 68 out. So I'm just going to check by plugging in 4 to make sure I can trust this website and get 68 out. So it's image notability, and I will do a screen share with my calculator. And I'm going to just check to make sure that was a good website to be referencing. And there it is. And you can check the other numbers. In my mind, I just checked 0, -4. So there is the equation. Looks like that was a pretty good website. I'll go ahead and fix that hyperlink on your end. Number 4 deals with factoring. Now, some of you might be able to just recognize this is the difference of perfect squares. Some of you might not be able to recognize that this is the difference of perfect squares. Let's say that you can't recognize that this is the difference of perfect squares. You'll do a times c and b. In this case, b is missing, so it's 0. A times c is 9 times, excuse me, please, 9 times -16. So -144. So I need two magic numbers that multiply to -144 but add to 0. So 12 and -12 are my magic numbers. If you're a grouper, go to grouping. If you're a boxing, go to boxing. Pull out a GCF, no matter what method you are, and then state your final answer. Please make sure you are always looking for a GCF before you go to the box or before you go to graph grouping. This problem did not have a GCF, so I didn't look for that at the beginning because I kind of eyed that up that I didn't need it. Number 5 wants you to solve the quadratic. So when we say solve, we're actually going to get a value for x. So we need to set this equal to 0. Okay, so what I'm going to do is move that 5 over. And because this is an x squared problem, I'm going to do the quadratic formula. Now, some of you might like to complete the square. I don't know many people who do. Some of you might be like, I'm going to try to factor this to solve it. I'm just going to do the quadratic formula because the quadratic formula works all of the time. So we identify a, b, and c. Opposite b plus or minus square root of b squared minus 4a and c all over 2a. Let's keep going with that. Draw an arrow up here. So it's going to be 7 squared in parentheses minus 4 times a times c. So 109. That's an interesting number. Over negative 6. Let me just check that 109 again. 7 squared minus, yeah, I guess that's right. I didn't do it. Yeah, that's good. So I got to think, like, is there anything that goes into 109, like from your square list? Like if you do 109 divided by 81, that's certainly not going to work. 109 divided by 64, that's not going to work. 109 divided by 49, that's not going to work. 109 divided by 36 won't work. 109 divided by 25 won't work. 109 divided by 16 won't work. Divided by 9 is not going to work. Divided by 4 is not going to work. So there's nothing that goes into 109. So the only thing that I would ask you to do is bring the negative to the top. And you might, that's really it. That's all you need right there. You might be like, well, you didn't change it to a negative square root of 109. Well, technically the plus and minus would go upside down, but it doesn't make a difference. Let's try that again. Hopefully we'll get an I this time. I would like you guys to practice imaginary numbers. So it's already set equal to 0. So this is a negative 1. So opposite b plus or minus square root of b squared minus 4ac all over 2a. And let's see, let's keep working that out. Bottom is going to be 8. Let's do negative 1 in parentheses. Please make sure you include your parentheses. If you do not include parentheses with negatives, it will not work properly. So negative 47, good. We finally have an I problem. And I'm hoping you know why this is an I problem. Anytime we have a negative inside our square root, we're going to pull a negative out. So it's 1 plus or minus I square root of 47 all over 8. Now the only thing we should check is if anything goes into 47. So I can make the list if you want. What would go into 47? So like I'll just start at 49. 7 squared is 49. Does 49 go in there? No. Does 36 go in there? No. Does 25 go in there? No. Does 16 go in there? No. 9 or 4. So since none of those numbers go into 47, I am done. You might want to find that list from way back when of your perfect squares. Okay, number 7. What does the discriminant, there's your key word there on this problem, of number, what is the discriminant of number 6 and what does it tell you? And so if you look back at your chapter 4, section 7 notes, you will find that the discriminant is b squared minus 4ac. So let's do that for number 6. So it has to be set equal to 0, which it is. So b squared is negative 1 squared minus 4ac. So negative 1 squared minus 4 times a times c. Let's zoom. A is 4. C is 3. We already actually did that, which was convenient. So the discriminant is negative 47 when we did that on our calculator. And since it's negative, that tells me that it has no real solutions. Going even further, it would told me it had 2 imaginary solutions. Now, I know that's what this particular problem was, but it would probably like be good if I discussed to you what if. So let's do like a what if. What if? What if we would have got a positive? Well, you should say two real solutions. What if we would have got a negative, which is what we did? It's two imaginary solutions. Or you might say no real solutions, also known as no real. What if we got a 0? You would say one real solution. Okay, so that's the work for the discriminant. Please mark down discriminant is b squared minus 4ac. All right. Let's take a look at imaginary numbers some more. So anytime we have a square root of a negative, that's going to be an imaginary answer. So we may as well just take that I out now. Like that. That negative comes out and becomes an I. Miss Miles says, take out your eyes, but don't go blind. And what goes into 75? So like you can start listing your perfect squares. Like 10 squared is 100, 9 squared is 81, 64 for 8 squared, 49 for 7 squared, 36, 25, 16, 9, and 4. These are the important numbers. And the question becomes, do any of these important numbers go into 75? Excuse me, 175. The answer is yes, right? 25 times, let's check it out. 175 divided by 25, 7. So let's finish this answer. So I picked 25. So it's going to be I square root. If you like to see it separate, this step isn't necessary. Oh, that's a really funny looking 2, isn't it? There you go. How's that? There you go. Okay, so we have I squared of 25 times 7. So the 25 becomes a 5 because you take its square root and the 7 is trapped inside. That's your answer. And number 9, practice some more imaginary numbers. So number 9, I am including a lot on this one. The first thing you need to know is if you have an I on the bottom, like that's not okay. So you have to multiply by the conjugate, which is 2 plus I. And I'm going to work out the entire bottom first, and then I will work out the entire numerator. Okay, so working out the entire denominator, I do 2 times 2 is 4. I'm going to zoom in so you can see the arcs. 2 times I is positive 2I on that one. Negative I times 2 is negative 2I on that one. Negative I times positive I is negative I squared. So the 2's cancel out. Boom, boom. And this is really 4 minus negative 1. Remember, I squared is negative 1. So that's really 4 plus 1. So the entire denominator turns into a 5. You might want to replay that video just so you can make sure you remember that. Okay. Now for the top, I'll change the color just so there's a little bit of differentiation there. Okay, zoom in. 6 times 2 is 12. 6 times I is 6I. Negative 8I times 2 is minus 16I. And negative 8I times I is negative 8I squared, because you had I twice, so I times I is I squared. So on the top, let's take a look at this. So the 6, I'm going to just rewrite this because this is getting messy. All right, so I definitely like the 12. These two make negative 10I because they're like terms. Okay, so this is really a minus an 8 with a negative 1 because I squared is negative 1, which means it changes the sign, which means it changes to plus 8. I squared never has an I, like it will always change the sign. That's its goal. It turns into a negative 1. So if there was a negative 8 there, which it was, negative 1 times negative 8 is positive 8. So for the entire top, I can put the 12 and the 8 together to get 20 minus 10I. So let's talk about our final answer. This is a really good start to our final answer, but if you notice, everything divides by 5. So I'm going to divide everything by 5. Final answer, 4 minus 2I over 1. So that's my final answer. So like on the final, let's say that all you're given is, look at my highlight. Let's say all you're given is that. Okay, then the final answer would be 20 minus 10i. But if like it's a fraction, you got to get the I out of the denominator. If you need more help with that, please look at your chapter 4, section 8 notes. We took 2 days to do this kind of stuff. So if you want to look, there's 2 sets of notes that you can reference if you need more help with that. Number 10 is also from 4.8. It's graphing and labeling complex numbers. So it says on the complex plane. What that means, so I'm trying to zoom in for you so you can see that. On the guess I just need to get rid of my calculator. There you go. On the complex plane. What you need to, this is actually much easier than what you might think. That's your imaginary axis. This is your real axis. So this means to go over 5, positive 5 on your real axis, up positive 2 on your imaginary. So 1, 2, 3, 4, 5, 1, 2. And it's that easy. That's how you graph and label the point, and this is point G. Number 11 is from chapter 4, section 9. The good news is it relates a lot to chapter 4, section 7, which is the quadratic formula, which we've been doing for eons now. All right, so you need to solve your final answer. I'll even put a box here for it. Your final answer is going to be probably 2 points, an x and a y value on both of them. It's where these are 2 parabolas. I mean, you can even graph them together and you'll see that they probably cross in 2 spots, or maybe they don't cross at all. So let's see. You know what? I have the time. You can fast forward. That will be your choice if you want to fast forward or not. I want to go ahead and graph them so I know what I'm looking for a final answer. So I'll hit y equals, clear that out. You can fast forward through this if you want to. I like to be thorough. Negative x squared. I'm putting 1 in y. I'm putting the first one in y1, the second one in y2. And I'm gonna hit graph. So if I look at my graph, let me pull down here. Looks like they're gonna cross in 2 spots, like the red and the blue. If I could see the whole picture, I'm gonna guess it will cross in 2 spots. All right, let's do this thing. So they both equal y, which means we can set this equation equal to this equation, because it's like if a equals b and b equals c, then a equals c. The transitive property tells me that these 2 are equal to each other. So that's x squared minus 3x plus 6 equals negative x squared plus 7x plus 6. Now, just so you know, sometimes like you don't have 2 parabolas. Sometimes you could have a parabola and a line. They might cross once, they might cross twice, they might not cross at all. Okay, so I would suggest just putting them in your y equals and looking at the graph. Now, we know we have to set this equal to 0, so I'm going to add x squared. I'm going to subtract 7x. I'm going to subtract 6. Oh, that's interesting. So it's 2x squared minus 10x plus 0 equals 0. Now, some of you might be like, Miss Angeli, I can take a GCF and solve here. Go for it. You're more than welcome to do that. I'll do the quadratic formula just like so I stay consistent with everything that I have been doing. So opposite b plus or minus square root of b squared minus 4ac all over 2a. That's going to be, when you put that in your calculator, I'm pretty darn certain you're going to get 100 over 4. And that's going to be 10 plus or minus the square root of 100 is 10 over 4. So I'm going to do 10 plus 10 over 4 and 10 minus 10 over 4. I might be going really fast. Please feel free to slow down the video, rewind it, try it on your own, okay? Just because I go this fast doesn't mean you have to keep up with me. Like that's why you can hit the pause button if you need it, okay? So 10 plus 10 is 20 over 4. 10 minus 10 is 0 over 4. 20 over 4 is 5. 0 over 4 is 0. So, okay, you get this far and you get these 2 really nice answers. Those are your x values, okay? So what I'm going to do is those are my x values, 5 and 0. I'm going to put them in here. Now I got to go back and get my y values, okay? So my y values come from plugging those in. I'm going to choose to plug them into this one because that looks a lot easier than the negative in the front. So I'm going to do 5 squared minus 3 times 5 plus 6. Let's see, that's going to be 25. 25 minus 15 is 10. 10 plus 6 is 16. And then I'm going to plug in 0. So 0 squared minus 3 times 0 plus 6, that's just 6. Now, I did that in my head. I don't trust it. So what I'm going to do is I'm just going to check it real quick on the calculator by going to my table and putting in 5 and 0. And when I put in 5, I got 16 on both equations. And when I put in 0, I got 6 on both equations. So I know that we got it right. And I don't know, that's kind of cool. All right, that takes care of chapter 4. I hope you had as much fun as I did.